Alright guys, it is a beautiful day to be working on the Civic. We are working on the turbo manifold for the new turbo setup in our Time Attack Civic. This video is going to be all about how I mocked up and built the turbo manifold. Later videos we are going to be building the engine and the transmission, converting it to E85, and trying to make a reliable 500 horsepower. Alright, so this is the current setup on the car. You can see this half radiator and intake is taking up way too much room, so that's going to have to go and make room for a full-size radiator, and then we'll snake our intercooler piping up down through here. This cold air intake might get reused. It's awful big, might end up on my friend's car. Alright, here's the setup in the bandsaw. So we have a jig, which allows us to get 11.5 degrees. And then after we make our first cut, since this is a four tube collector, we need to turn this 90 degrees off center, and you have to measure from the cut. So I leveled out on the bandsaw. And then we go for 0 degrees on the cut. A little off right now. It takes some dialing in. And then that'll give us perfect cuts for our collector. Basically, this is a piece of angle iron, the hole drilled in it, and a bolt welded to it. Pretty simple. Got it all templated out. We are ready to cut the hole. Probably going to start with a drill bit, maybe a hole saw, and then get in there with the die grinder. It's going to take a while. We'll be back. Alright, we got all the runners fitted up after welding. Took a little bit of adjustment to get them back where they were happy. Now that everything is tacked in place. Alright, so here is the setup for the plugs to plug the tube and fill it full of gas. Now these, you can buy these pre-made, and they're pretty expensive. They're about 40-50 bucks a piece. I found these on Amazon. They're a silicone plug used in like the food industry for closing beakers, and they don't come with a hole. So you just drill a hole in it, and then you can put a diffuser and a barb fitting. And I got 5 plugs for 10 bucks. These were 8 bucks. I got 10 of them, and then these were like 9 bucks. 12 of them. So pretty simple, cheap way to make a bunch of plugs. And you're also going to need it for your Purge vlog, so good way to save. Alright, so when you're fitting up these tubes, when you go to weld it, it will actually shrink and become slightly shorter than what you originally started with. So when you're fitting them up, you can start your first tube slightly off. Say it's gonna shrink this way, so you tack it over slightly, and that will give you the wiggle room for it to come in. Another thing you can do, say if you have 2 runners already made and this is pretty much where it's going to live, you can wait and make your other 2 runners afterwards and fit them up close to what they're going to be and then weld them in place. So say I would take this tube, cap it, fully weld it. Now this isn't going to move once it's welded. I do the same to this piece. Say I like where it's going to be, fully weld this joint, and now when I'm fitting this joint, I can grind a little bit, I can move it around and get it perfectly where I want. Once it's perfectly in line and it has a little bit of room to move, say like you're not aiming it directly where you want it to go, you're aiming it maybe a 1/16 off, weld that piece all the way in and then use your final piece and that piece to fit it into the final location that it's going to live. Another thing, say it's better to make things too short than too long, because it in regards to, you'd rather have it slightly that way, a little bit too much, because if you squeeze the tube, say you squeeze the tube right here, it will open up and it'll push it that way. It's hard to get it to move this way, but if you squeeze it, you can get maybe a 1/16 of an inch and get it to move over. Another thing, when you're trying to get full penetration on this thick wall tubing, there's a couple ways to do it. I am doing a knife edge with 0 root gap. Now the root of the weld is the very tip right there. That is the first pass. Now to get full penetration, usually what you would do is have a landing ground into the bevel like this. So there's a little 1/16 of a flat. And now to get a full penetration, you have to do what's called keyholing and have a root gap, typically about a 1/16 of an inch or 3/32. And that gives you some gap to get in there and have the weld fall into the hole and put a nice bead on the backside without having lack of fusion. When you're building a complex header, holding a pipe with a gap and then trying to use filler rod to get the filler in there to make a tack is very, very difficult. So what I'm doing is putting a knife edge, so 0 landing and 0 root gap. So I'm putting them up and having them touch, and then I will do a autogenous weld, which is a weld without filler rod, and that'll come in here, get it hot enough to weld full penetration. And then you come with what's called a cap pass, and that fills in the divot and gives you a slightly proud bead. All right, finishing up some of the welds on the last runner, it's going to be super close to the end, so we'll actually melt the silicone plug. So that's why I'm using the aluminum foil here. Here's the torch setup. It's a CK flex lock torch with a ceramic number 10 glass lens with a filter. I found that if I use a blunted tungsten, it'll give me a little better penetration and better arc stability. But you're gonna need something really small and short like this to get in some of the tight areas. Alright, now we're going to be welding our runners onto our flange. This is a 1018 mild steel, and the runners are 304 stainless. The benefit of running a mild steel flange is that it has a expansion rate that's half of mild steel. So it will expand a lot less when it gets hot and put less stress on your studs. Making it less likely to crack. Now, when you're welding dissimilar metals, you have to use a special TIG rod, which is a 309. All of the other runners are welded with a 308 rod. So we're going to get these welded up. We're going to take it very slow and make sure to cool down in between each pass. Hopefully it's not warped too bad, but this will probably have to get taken down on a belt sander to make it flat again. Alright, here we're going to be bending up one of our tungstens. It really can help you get out of a sticky situation and allow you to get in those nooks and crannies where otherwise you would never be able to get into. It's a very useful little trick. Basically, we're just going to strike an arc on the tungsten, bend it up with some pliers, and that's that. Alright, we're welding up our runners here, trying to take it slow. You know, you get excited, but you get it a little too hot and it will warp on you. Just want to say how rewarding this process has been. You know, building something from scratch and seeing the end result, it really just makes you feel good at the end of the day. And getting you out, getting you in the shop, everyone needs to do this at least once in their life. Alright guys, so there's our manifold all finished up. It's been a really fun project, very rewarding. I wanted to go over how heavy this thing's going to be, being thick wall tubing. So let's put it on the scale. Almost 15 pounds. Now let's compare that to the 4-to-1 header that was on there originally. This is thin wall, but it is much bigger. We're at 16 pounds, so it's about a pound lighter. Of course, we won't be using all of the exhaust that goes along with the 4-to-1 header. Now let's get a total weight with the blow-off valve and turbo. Blow-off valve and clamps is about 3 pounds, and then our turbo totals up to 17 pounds, so about 15 pounds for the turbo. So altogether we're looking at gaining 16 pounds on the hot side. Of course we have to do intercooler piping and the intercooler, but that's not too bad. 15 pounds intercooler and piping is probably 20 pounds. So we're looking at about 35 pounds gained. I want to go over a little bit on how much this thing costs to build. You know, building one of these, you obviously want to save some money over purchasing one. Starting off, the tubing, it was $230. The flange was $55. The V-band and the clamps were $60. All of the welding gas that it took to back purge this thing and weld it out fully took about a half a tank on my 330 cubic inch bottle. That was $50 and about $10 in filler rod, totaling out to $405. Not too bad. It came in right around the price of the cheap eBay Chinese manifolds, and of course we got to build it ourselves to the exact application that we needed, which was fitting this counter rotation turbo. I think it's gonna flow very good. They aren't quite equal length headers. They're within 2.5 inches of each other. I hope it lasts a long time. Of course, I'll give you updates on how it's performing. But yeah, next we're going to be working on the cold side. So we will be redoing the radiator, integrating an intercooler and a oil cooler, running all of the aluminum piping, and then we're gonna have to pull the motor, and it's going to get rebuilt with forged rods and pistons. It needs a looser ring gap and piston to wall clearance. And then also we have to rebuild the transmission and figure out how to make it hold the 500 horsepower. The factory RSX Type S transmissions don't really like to hold above 400 to 350. So we might be putting a dog gear engagement with straight cut gears, or we might just rebuild it, carbon synchros, and see how long it lasts. I appreciate you watching and following along. You know, like and subscribe, all that. Make sure to get out in the garage and build something, you know, add some value to this planet.